Look into the eyes of a chimpanzee, and you're staring at your closest living relative. We share 98.8% of our DNA with these remarkable creatures. Yet, here we are, building cities, writing symphonies, and launching rockets into space, while they remain in the trees. This raises one of the most common questions in evolutionary biology. If humans evolved from apes, why did apes stop evolving into humans? The answer might surprise you. Because the truth is, they never started. Before we dive deep into this mystery, we need to address the elephant in the room, or rather, the ape in the evolutionary tree. The question itself contains a fundamental misunderstanding that has plagued public perception of evolution for over 150 years. When Charles Darwin published On the Origin of Species, in 1859, he never claimed that humans evolved from modern apes. That's not how evolution works. Instead, Darwin proposed something far more elegant: humans and modern apes share a common ancestor. Think of it like this: you and your cousin both descended from your grandparents, but your cousin didn't descend from you, and you didn't descend from your cousin. You're both branches on the same family tree. The same is true for humans and modern apes. We're evolutionary cousins, not parent and child. So the real question isn't, why did apes stop evolving into humans, but rather, why did our evolutionary paths diverge, and why have modern apes remained relatively similar to our common ancestor while humans changed so dramatically? Now that's a question worth exploring. Our story begins between 6 and 7 million years ago in the forests of Africa. Here lived the last common ancestor we shared with chimpanzees and bonobos, a creature that was neither human nor modern ape, but something in between. Scientists don't have a complete picture of what this ancestor looked like, but based on fossil evidence and comparative anatomy, we can make educated guesses. This creature was likely smaller than modern humans, covered in hair, and spent significant time in trees. It probably walked on 4 limbs when on the ground, using a form of locomotion called knuckle walking, just like modern chimps and gorillas do today. Then, something happened. The climate began to change. East Africa started drying out. Dense forests gave way to more open woodlands and eventually savannas. This environmental shift created a fork in the evolutionary road. Some populations of our common ancestor remained in the forested regions where food was still abundant in the trees. These populations would eventually evolve into modern chimpanzees, bonobos, and gorillas. They had no reason to change dramatically, their environment still supported their lifestyle. But other populations found themselves in increasingly open landscapes. And for them, evolution had different plans. The populations that ventured into more open environments faced new challenges. In the savanna, there were fewer trees to climb for safety or food. Predators were everywhere. The ability to see over tall grass became a matter of survival. This is where one of humanity's defining features emerged: bipedalism, walking upright on 2 legs. Now, chimpanzees can walk on 2 legs occasionally, and they sometimes do. But it's not their primary mode of locomotion. For our ancestors, however, bipedalism became the default. Walking upright freed their hands, allowed them to see farther, and was more energy efficient for traveling long distances across open terrain. But this raises an interesting question: if bipedalism was so advantageous, why didn't the forest-dwelling populations develop it too? The answer lies in one of evolution's fundamental principles: natural selection only favors traits that provide an advantage in a specific environment. In the dense forests, climbing ability was far more valuable than upright walking. Chimpanzees and evolution isn't about becoming better, in some absolute sense, it's about becoming better suited to your specific environment. This is crucial to understanding why modern apes evolved the way they did. Chimpanzees, gorillas, and orangutans faced evolutionary pressures that shaped them into remarkably successful species. Chimpanzees developed sophisticated social structures, impressive problem-solving abilities, and even tool use. They crack nuts with stones, fish for termites with sticks, and have complex cultures that vary between different populations. Gorillas evolved incredible strength and size, allowing them to process large quantities of vegetation and defend their families from predators. Orangutans became the acrobats of the ape world, with incredibly long arms perfect for life in the Southeast Asian rainforest canopy. Each species evolved to master their particular niche. They weren't standing still, they were actively evolving to become better at being chimpanzees, gorillas, and orangutans. But back in Africa, our ancestors were evolving to become something entirely different. The open savanna presented unique challenges. Our ancestors couldn't rely on the forest's bounty anymore. They needed to hunt, scavenge, and eventually control fire. They needed to communicate more complex ideas to coordinate hunting strategies. They needed to create more sophisticated tools. Each of these pressures drove further changes: larger brains, more dexterous hands, more complex vocal anatomy, and social structures built around cooperation and knowledge sharing. Perhaps the most dramatic difference between humans and other apes is our brain size. The average adult human brain weighs about 1,350 grams. A chimpanzee's brain? Around 400 grams. That's more than 3 times smaller. But here's what's fascinating: brain size isn't everything. Elephants have brains that weigh 4 times as much as ours. Whales have even larger brains. What matters is the brain-to-body ratio and, more importantly, how the brain is organized. The human brain is an energy monster. It comprises only 2% of our body weight but consumes about 20% of our energy. For our ancestors to develop larger brains, they needed reliable access to high-quality, calorie-dense food. This meant meat, cooked food, and eventually agriculture. Chimpanzees and other apes primarily eat fruits, leaves, and occasionally insects or small animals. This diet provided enough energy for their lifestyle but wouldn't support the metabolic demands of a human-sized brain. Here's the key insight: chimpanzees didn't need larger brains. Their existing brain size was perfectly adequate, even optimal, for their environment. A larger brain would have been a liability, demanding more energy without providing proportional benefits in the forest canopy. Evolution doesn't waste resources on unnecessary features. If a trait isn't providing an advantage, it won't be selected for, no matter how impressive it might seem. There's another crucial factor in why modern apes remained relatively similar to the common ancestor: environmental stability. While the regions where human ancestors evolved experienced dramatic climate fluctuations, wet periods alternating with droughts, forests giving way to grasslands, the core rainforest habitats where apes lived remained relatively stable. Evolutionary change happens fastest when environments change or when populations encounter new habitats. When conditions are stable, there's less pressure to evolve dramatically. The species that are already well adapted simply continue to thrive. The great apes found themselves in a Goldilocks zone. Their environments were rich enough to support them, stable enough not to force dramatic changes, and their adaptations were good enough to keep them competitive. They weren't stuck in evolutionary amber, they continued to evolve, just not in the direction that led to human-like features. Why would they? Those features wouldn't help a chimpanzee catch more termites or a gorilla digest more leaves. Let's talk about the mechanics of evolution for a moment. When populations split and stop interbreeding, their genes begin to diverge through several mechanisms: natural selection, genetic drift, and mutation. Natural selection, the survival of the fittest, is the process most people know about. But genetic drift plays an equally important role, especially in small populations. Genetic drift is random change in gene frequencies over time, not driven by adaptation but by chance. When the human and ape lineages separated 6 to 7 million years ago, they stopped exchanging genes. From that point forward, each population accumulated its own unique mutations and variations. Over millions of years, these small changes accumulated into the dramatic differences we see today. The important thing to understand is that both lineages were evolving. Neither was standing still. The human lineage happened to evolve features like larger brains, less body hair, and bipedalism. The ape lineages evolved their own unique features: chimpanzees developed stronger upper body strength and specialized social behaviors, gorillas evolved impressive size and specialized digestive systems for processing fibrous plants. Every species on Earth today, including all the great apes, represents the latest chapter in an evolutionary story that's been unfolding for billions of years. None of them are less evolved than humans. So why does the misconception persist? Why do people still think humans evolved from apes, or that evolution is a linear progression from primitive to advanced? Part of the problem is that famous image, the March of Progress, showing a line of figures gradually transitioning from a hunched ape to an upright human. This illustration, first published in 1965, became one of the most iconic images in science. It's been reproduced countless times in textbooks, museums, and popular media. But it's fundamentally misleading. Evolution isn't a ladder, it's a bush. Throughout human evolutionary history, multiple species of hominins coexisted. Homo sapiens, modern humans, lived alongside Neanderthals, Denisovans, Homo erectus, and possibly others. These weren't stages in a progression, they were different branches on the evolutionary tree, pursuing different strategies for survival. Most of these branches eventually went extinct, leaving Homo sapiens as the only surviving member of the human family. But for millions of years, we weren't alone. Similarly, today's great apes aren't frozen ancestors or evolutionary dead ends. They're the latest iterations of their own evolutionary lineages, just as modern and just as evolved as we are. They're just evolved for different things. Here's a thought experiment: drop a human and a chimpanzee in a dense rainforest and see who survives longer. My money's on the chimp. A chimpanzee can climb trees with ease, identify edible plants by sight and smell, construct sleeping nests, and navigate through the canopy with grace and efficiency. A human, even a physically fit one, would struggle to keep up. Now, reverse the scenario. Place a chimpanzee in a modern city, and it would be equally lost. The point is this: neither species is objectively better than the other. We're each exquisitely adapted to our respective niches. Evolution doesn't have a goal. It doesn't aim for intelligence, or bipedalism, or any other trait. It simply favors whatever helps organisms survive and reproduce in their current environment. For humans, that meant bigger brains and tool use. For chimpanzees, it meant maintaining the strength and climbing ability that serves them so well in the trees. The same principle applies to all the great apes. Orangutans are perfectly adapted to their rainforest homes in Southeast Asia. Gorillas are optimized for their mountainous terrain. Bonobos have developed unique social structures that allow them to thrive in their specific environment. None of these species stopped evolving. They're all actively evolving right now, this very moment, responding to environmental pressures and accumulating genetic changes that will shape their descendants millions of years from now. The difference is that the pressures they face don't favor human-like traits. Looking forward, what does the future hold for the great apes? Will they continue on their current evolutionary paths, or will new pressures drive them in unexpected directions? Unfortunately, the greatest pressure modern apes face isn't a natural one, it's us. Habitat destruction, climate change, poaching, and disease have pushed many ape populations to the brink of extinction. Orangutans, gorillas, bonobos, and chimpanzees are all endangered or critically endangered. In the wild, evolution operates on timescales of thousands and millions of years. But human impact operates on timescales of decades. We're changing their environments faster than evolution can respond. If we want to see how apes might evolve in the future, we first need to ensure they have a future. Conservation efforts around the world are working to protect these remarkable species and their habitats. The story of human and ape evolution isn't finished. Our destinies remain intertwined, not through continued biological evolution. Our species won't be exchanging genes anytime soon, but through our shared ecosystem and our responsibility as the one species capable of protecting or destroying the others. So, why did apes stop evolving into humans? They didn't, because they never started. Humans didn't evolve from modern apes. We evolved alongside them, from a common ancestor that was neither human nor modern ape. That ancestor's descendants split into multiple lineages, each following its own evolutionary path shaped by its environment, challenges, and opportunities. The lineage that led to humans faced pressures that favored bipedalism, tool use, and large brains. The lineages that led to modern apes faced different pressures that favored their own unique adaptations, climbing ability, social sophistication, specialized diets, and remarkable strength. Neither path is better or worse, more or less evolved. They're simply different solutions to different problems. Every living species on Earth, from bacteria to blue whales, from mushrooms to mountain gorillas, represents an unbroken chain of evolutionary success stretching back billions of years to the first self-replicating molecules. Every species alive today is, by definition, a winner in the game of survival. When you look into the eyes of a chimpanzee, you're not looking at a failed human or an evolutionary relic. You're looking at a fellow traveler on this extraordinary journey of life, a distant cousin who took a different path through the forest of time. And both of our paths are equally valid, equally remarkable, and equally deserving of wonder. If you enjoyed this deep dive into evolutionary biology, hit that like button and subscribe for more science content. Drop a comment below with your thoughts or questions. What aspect of human evolution fascinates you most? And if you want to learn more about our evolutionary cousins, check out our video on the secret intelligence of bonobos linked in the description. Thanks for watching, and I'll see you in the next one.